So hello everyone. Today it is going to be an interesting video. Have you ever wondered why, how the universe began, how the everything that is around us, the matter, the surrounding, how it came into existence, what existed before them? Is there is something from which all these things made up of, and is there is any time when these things doesn't exist, and how they get formed, and how this our present form of universe came into existence? So today we are going to talk about one of the theory for the formation of the universe, which is Big Bang. So it's going to be very interesting for the science lovers. So we first we are going to its early uh, when it's so first we are going to go to the initials of the Big Bang theory, how its development in this theory takes place, how all the concepts, all the information has been made. So first of all, we have to understand that. So we have to understand that how from the beginning. So let's start from the beginning, very beginning of this theory. So as we know that the color of light depends on many things, color of any object. So color doesn't depend only upon the appearance of an object, but it also depends upon the speed of the object. So this effect is known as Doppler shift. Like when we have seen an ambulance going away from us, may sound different from the ambulance coming toward us. So in the case of the light, this effect is called as redshift. So for an object moving toward us, the distance that the light have to travel to come to our eyes will be less as compared to the object which is going away from us. So for an object which is going away from us, the light coming from it have to travel more distance, so it will have a longer wavelength as compared to the object coming toward us. So it will be more toward the red end of the band, so it appears more red than actually it is. So this was the observation observed first by the Hubble. Hubble was a scientist on which the name of the telescope, Hubble telescope, has been named. So what Hubble observed that every single galaxy is red shifted. So he absorbed in the space a very interesting thing, that every galaxy, every planet, and everything in the space is red shifted. Red shifted means it appears more red than actually it is. Means they are moving away from us. And the most important and interesting thing that Hubble observed, that the more distant object, more far objects which are more far from us are more appears more red than actually they are. Means this effect of the red shift is it's seen to a more extent in distant object as in nearby objects. So this means that the objects which are beyond us are moving faster than the objects which are closer to us. It means that our space is expanding. It simply means that our space is expanding, and the objects which are more farther are moving at a greater speed as compared to the objects which are nearby to us. So this is very awesome observation as noted by the uh, Hubble. In 1964, the researcher in the Bell Labs, New Jersey, are doing experiment in which they are receiving the radio waves from the space in order to study about it. So what they found, something strange, that along with all the light waves, all the radio waves that is coming, there is always one disturbance that come along. After doing their best to remove all the obstacle that coming in the path of the radio waves, they always found a noise which is present every time they do the experiment. So they found that this is not coming from the source, from the buildings or from the birds or from the New York City that is located 20 kilometers away from it, it is actually coming from the space. And today we know very much about it. It was the property of universe now recognized as the cosmic microwave background radiation. It is one of the proof of the time when the universe was very small and hot. The expansion of universe spread the radiation out and converting the heat waves into the microwaves, and these radiation are the first proof of the picture of the expansion. These microwaves are the first proof of the theory of the Big Bang. Big Bang and the space and the picture that we got today of the universe after 13.8 billion years before its birth. So let's dive now more deeper. So Roche-Metrage models of expanding universe was based on the Albert Einstein theory of general relativity. When Albert Einstein heard about this theory, he felt quite uncomfortable, and this physics, according to him, this physics was true according to the maths, but its physics is not correct according to him. According to the Albert Einstein, the expanding universe must have a origin, and its origin should be a single point. If it's expanding, so its origin must be a single point. So, so Lemaitre argued for the pre-naval atom having the potential for the creation of our immeasurable universe, and all the matters, and according to him all the matters and energy at that time was concentrated at a single point, which he called singularity, and all the matters and energy, due to concentrated at a single point, its density is like approaches to infinity, and its temperature also expands to infinity, and all the physics all the rules that we have seen today got break down there. So now we are starting the chapter 2, in which we study, in which we know why the universe expands. Why means after starting from a single point or like very small finite particles, why the universe expands so much fast, so much to infinite, and so much big. So we cover two theories in it. The first theory is of gravitational singularity. So according to this theory, when there is no time, no position, and no existence of the time, every matter and energy was concentrated to a infinitely small point, which is called as gravitational singularity. The gravity due to it was infinite, and it has no light to consume because everything was inside it, even the light was inside it. But the problem with this theory is that it leads to a universe which looks, if it truly happens, it will lead to a universe which will look very different from the universe that exists today. So there are two arguments to support this. First is that the universe created from a gravitational singularity will have very high variation of density from one end to another end of the cosmos or in the space. And but today when we see the space today around us, the space is quite uniform, means the stars, the planet, the distribution of the matter and energy in the universe today is quite uniform, but the universe that would result from it will be quite non-uniform, and the the variation of temperature in it should be high. So one end of the universe will be like super cool, and other end will be like very super hot. But the universe that exists today is quite uniform. And the second theory, which is very interesting, is that is inflation theory. So according to it, during the inflationary period, at the earliest moment of the space, at the earliest moment of the birth of our universe, the space expanded double in size from one moment to another. It's expand exponentially, and even surpassing the speed of the light. Even surpassing the speed of the light means that it failed the uh, Albert Einstein theory of relativity. So, since the universe and the time was getting formed, the time has not begun. So, maybe the Albert Einstein theory of relativity was not applicable there. So, the expansion was quite fast and quite surpassing the speed of the light. That was enough to make space universe uniform as we see today. It is so fast that our universe get formed, get uniform. And when the exponential expansion ended, however we don't know why it ended, the energy has taken the form of the matter and the birth of universe takes place. So uh, so the question is that from where the expansion begins. In the gravitational singularity theory, as we saw that it started from nothing. That was infinitely small point which is known as singularity. But in this theory, it can't be a single point. It can't be a singularity, because as we know that in exponential curves, it start from the exponential curve, so there must be something present. Maybe it's very small, but there must be something present before all. Before all, there must be something present, and so that to create something today, as we see the universe. So it doesn't start from zero, and 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 we don't know the answers to explain where the inflation why the inflation begins and why the inflation period get ended. And it could lead to a thought that of a world in pre-time which is beyond our imagination, and perhaps the events to takes place there. But the Big Bang is the first time the, that actually matters, first event that actually where actually the that actually matters, so which lead to the beginning of the time and space. Asking about what existed before the time is like asking what is south of South Pole. The question, you will say that the question is meaningless. What is south of South Pole? So why did universe expansion takes place? So before the birth of universe, there existed no time, no space, nothing. And so the question, asking the question that what existed before the creation of the universe will be a stupid question as that of asking like what existed south of South Pole. So what existed south of South Pole, what existed before the creation of universe is like beyond the present scope of our modern science, and it is impossible to answer because all the science, all the world that we see today, all the rules of physics broke there. And so it is not that we don't know about it, we can't know about what existed before the creation of universe. Maybe if Big Bang is true, so what existed before Big Bang, and why does it why what existed before Big Bang, how the what was there, it is like impossible to answer. It is not like we don't know and we can't know. So hope you like the video and hope you find this video informative. So for the next video, in the next video we will learn something new. And if you like the video, if you find it informative, please like the video. Thank you.